So you have everything else being the same. A 2-year bond is not as risky as a 10-year bond, or everything else being the same. For example, think of two 10-year bonds. One of them has 1% coupon, the other is a 20% coupon. The 20% coupon bond is less risky. Let's kind of see that. Let's make this original bond 30 years, okay? Uh, oops, 1.156. That's the old price. Now it's going to be a 27-year bond with 392.4. As you can see, you lost close to 42% even after you added the coupons. So let me make these red. With the 10-year bond, this number was only about 13% or so. The 30-year bond is much higher. Let's do a 5-year bond. Oops. For a 5-year bond, that's the original price. Now that bond is for 2 years. You only lost about less than 2%. So the lower is the maturity, or the shorter is the maturity, the less interest rate risk there is. In terms of coupons, let's see the extreme case, zero coupon. Let's think about a 30-year bond. Well, it pays no coupons anyway. At the time we purchased, that bond would have been worth 707. You would have lost more than half of the bond value. And remember, don't think like an amateur. Just because you didn't sell the bond yet, didn't mean you didn't lose it. Okay? A lot of people think, oh, I haven't sold it. Well, in order to get it, either A, the yields have to go down again, or you have to wait for 30 years. That's the problem. But if you're waiting for 30 years, you're earning only 1.156% on your original investment. Now let's think about a 20% coupon bond. Since coupon is so high, you're going to have to pay a lot of money. Okay. Now 3 years has passed. I mean, you still lost quite a bit of money, but not as much. In this case, you lost about slightly over a quarter of your money. With the zero coupon bond, you lost over half of your money. And the higher is the coupon, the lower is the risk. And there's a good reason why that is so. Higher is the coupon, shorter is the effective maturity of the bond payments, bond cash flow. In a 30-year bond, you're waiting 30 years for the last payment, but there are a lot of payments in the meantime. You get some money in 6 months, some money in 1 year, so on and so forth. Effective maturity of a set of cash flows is known as the Macaulay duration. This has nothing to do with the kid in Home Alone. There was a guy named Robert Macaulay back in 1938 defined this amount is equal to the weighted average of individual maturities where weights are the present value of those cash flows. Let me write that as a formula. Suppose you have T cash flows that are CT and T. That means T periods from now, you're going to get $CT. And T equals 1 to cap T. PV of the teeth cash flow times T. So I multiply each present value with its length, add them up, and divide the whole thing by the present value. Well, that present value of some of the present values is the value of the bond anyway. We can do that we can do that. I'm going to do that in the sheet itself right now, but on Wednesday we're going to actually write a nice little not MBA, VBA function to calculate that. But for now, I'm going to do something that's going to handle up to 1200 periods. Which means it can handle up to monthly bonds with 100 years. What's the cash? If this period is greater than, where is that? Number of coupons, that means we no longer have anything. It's 0. And I'm going to make that a fixed number. Otherwise, if this period is exactly equal to number of coupons. Well, that's the last period, which means I'm going to get the face value plus the coupon amount. Otherwise, the only remaining alternative, it is anything before the last period. I'm just going to get the coupon amount. I'm going to remember $8 is number of coupons. $1 is face value. $7 is the coupon amount. I do these ifs so that it can handle, different stuff. If you guys are done with the formula, I'm going to continue. I mean, I will post this version anyway, but if you want to do it yourself, in this case, this is a 27-year-old bond with semi-annual coupons. The last period, I get face value plus coupon. After that, nada. Or nichevo. So if this was a 5-year bond, 10% coupon. All right. Now let's calculate the present values of those. Take the cash divided by 1 plus the period rate. Raised to the power number of periods.